So, do you still remember me? I was here in the first aid. So, my name is Ko Ting Ling. I'm the director of both programs, IATP and GTEP. And today is my time to introduce mechanical engineering. So, I'm a professor from mechanical engineering, and there are actually quite complicated research directions in our department. So today I will be telling you what are the research directions mechanical engineering department is having, and also I will also introduce some of my research experience and research directions. So maybe in the future, if you're interested, you can consider mechanical engineering, or you can try to find a project with some professor in our department. Probably some professor already mentioned this. This is College of Engineering, and I'm gonna just talk about some stats. So from here, this is the number of professors in each. We have 4 departments and 1 graduate institute. And I know these numbers are all numbers. In our department, we do have 47 professors or more, actually, and more. This was an earlier number. I think we now have probably 50. And these are the number of students. Also, all numbers. And mechanical engineering is here. We do have a huge group. More undergraduate students, more master students, close amount of PhD students. And also you guys are from IATP and GTEP. These numbers are increasing also. So I'm just trying to use this to let you know mechanical engineering is the largest department, largest group, biggest gangster of College of Engineering. So to check the ranking around the world, we are ranking 247 in the QS ranking. So each department, each field is ranking approximately the same. And all these numbers are slightly higher than 247. That means engineering is the leading college of our school. Okay. Publication-wise, we do have, if you are looking for publishing, chemical engineering probably publish more. Chemical engineering is the department which publishes the most in engineering. We are like at the middle, okay? But we are still quite productive. Budget-wise, I don't think you need to know this. This is you guys, IATP, PBL. No, those are not necessary. Okay, so just for you to know, NE is the largest department. And I do have another slide. I'm sorry, this is also an old slide. I will show you this old slide, and then I will show you some more information from the internet, so you can recognize what's different. So I think I prepared this last year or 2 years ago. So in mechanical engineering, we have 5 original tracks, you can say tracks, or research divisions. First one is design and mechanics. Second one, manufacturing. Third one is thermal and fluid. The fourth one is control. The last one is materials. Okay, so I'm here, floating link. Okay, the blue ones, whoever is with the name, with the color of blue, are professors, full professors. So from here you can already tell most of our professors has many years of teaching experience and has been promoted to full professor. If you don't understand about professor positions, after you graduate as a PhD, you can apply for a professor position. The first job you can get is assistant professor in Taiwan and in most of the many foreign countries like USA. Then you can promote yourself to associate. Usually it requires you to accumulate a lot of research achievements for approximately 3 to 5 years. Then you need to work harder for another 3 to 5 years. Then you can promote to full professor. So whoever has are in the blue color probably already has teaching experiences for more than 10 years. I taught for 10 years. Green ones are associate professors. The orange ones are assistant professors. In this table, we only see 44, but like I said, this is all slide. There are more. Okay. What happened to our department is that we now have new divisions, new research divisions. But when we do that, we don't hire new professors. What does that mean? So we do have 2 more, actually 3 more. But this is old slide, so I only have 2 here. Later on, I will talk about the third one. We have 2 more special tracks. The first one is smart system and robotics. The second one is smart micro technologies. When we have special divisions, we don't truly hire new professors in those 2. Those are multidisciplinary research divisions. We borrow someone from the original 5. So the original 5 directions are the traditional research direction. Like myself, I could be, my background is actually optimization. So if I truly describe which research direction I belong to, I should say I belong to design. But recently, I work on robotics. In robotics, I need to develop control theories or control algorithms. So I'm a little bit like a design person and also work something related to control. So we realize nowadays research are so multidisciplinary. You cannot just work on one research topic. That's why we have multidisciplinary tracks, like this one, smart system and robotics. We have professors from design. We also have professors from control. So over here, we can collaborate more with people from different fields, different backgrounds. And it's easier for us to work with each other and share our experiences. And similarly, we do have professors for micro-technologies. The third multidisciplinary field is biomedical applications. I will talk about that later on. So next thing I would like to let you know is that we do have some important people in our department, whose names are now highlighted by bold blue fonts, including myself. I treat myself as an important person. Yeah, I'm a director, right? I should be important, right? So who are those guys? You can see we do have important person in every field. They play important roles in Taiwan Tech. First one is our president, Professor Yan Jiayu. He is a mechanical engineering professor. So he is from control. Okay, our president is from mechanical engineering. Second person is our dean. Dean of engineering is Professor Chen Mingzhi. He is from thermal and fluidics, also from NE. Okay? And then the third person that is important is Professor Guo Yuling and Professor Chen Pingquan. So Guo Yuling is our chairman. He is from materials. The vice chairman, Chen Pingquan, he is from same field as mine, design and mechanics. However, recently, Professor Chen Pingquan went to USA for a very long international collaboration. So he's gonna stay there for more than 1 year. And so his vice chairmanship, his duty for vice chairman is now passed to another person right here, is Xu Jingqi. Also in my division. Okay, let me continue to introduce important people. Okay, I'm the director for GDEP and ITP. Okay, and we do have 4 more professors who are research center directors. These 4. So there are several university level research centers. They are really huge centers where we have leading professor and also member professors who are from different departments. And in our department, we do have 4 people. They are directors of university level research centers. Let me introduce which are the 4. First one is Center for Intelligent Robotics actually. So Professor Lin Qiyu is the director. However, he retired this August. So he passed this director position to me. So I'm now 3 directors. I'm the director of IITP and GDEP, and also director of the Robotics Center. Okay. And we do have a center for high-speed 3D printing research. Professor Zheng Zhengyan is the director for 3D printing. And Professor Chen Zhaozhang from the manufacturing field, he is the director for CMP Innovation Center. What is CMP? It's a polishing. Let me show you. If you Google CMP, mechanical polishing. So what is this? So you know, in Taiwan, semiconductor is such an important industry, and they have silicon wafers, which is gonna be used for circuit chips. And sometimes they need those wafers to be thinner. How do you make a silicon wafer thinner? You cannot just you cannot scratch it by hand. You need to use some kind of tool to make it thinner or make it flat. So polishing is one way to make a silicon wafer thinner or flatter. And they use chemical and mechanical force. So basically, there are some agent between the tool and the wafer, and also have some force being applied. to polish the surface. So Professor Chen Zhaozhang is an important professor who works on polishing, wafer polishing, or microfabrication. Okay, back to my slide. There's one more center. This one, the Optomechatronics Technology Center. So basically, optics combined with electrical stuff and mechanical stuff. So what is mechatronic? Mechatronic is like a integrated system that has mechanical system and also electrical system. So it's an integration between electronics and mechanical. So usually we call them mechatronics. Okay? And not only they have integration of electronics and mechanical system, they also have optics. Okay? So Professor Xiu Fangzhong. And do you know, so who's from Paraguay? Anyone from Paraguay? Yeah. So we have a Taiwan Paraguay technology, right? Professor Xiu Fangzhong, he's the leading person who went to Paraguay to help Paraguay building that university. That's the person. So you can tell the professors from mechanical engineering, we are quite active in our school. Let me tell you more about the Paraguay University. So it's in Chinese. University is in Spanish. Let me find the English. No, the one is translated to English. So basically, Taiwan Paraguay Technical University. You can Polytechnic University, Taiwan Paraguay. So why do we have this? Taiwan and Paraguay is we have how do you call that? Like a agreement to work with each other. So several years ago, Paraguay government came to us and asked us whether Taiwan can help Paraguay to build technical university. So that was the time our government of international, maybe it's the Ministry of International Affairs, they came to us, came to Taiwan Tech, because we are the #1 technical university in Taiwan. They came to us and said, okay, can you find some professors in your school and then travel to Paraguay for years to help them build a technical university. So Professor Xiu was the person who did it. And now, because of this collaboration, we do see a lot of students from Paraguay and learn in Taiwan Tech. Now I would like to tell you more about the new division. But those information are from internet. So, nowadays our school's internet, the school's webpage is quite useful. You can find all those information online. So here are the divisions that I mentioned. Design and mechanics, manufacturing, thermal and fluidics, control, material, and smart system and robotics, smart microtechnology, and the new one, biomedical engineering. So again, the new division was built with the existing professors from the 5 divisions. Okay, so I would like to introduce some of the young professors, because they cannot be seen in the slide. I will just let you know the junior professors. Probably these two are not shown in my slide. So Professor Lin Dingzhen, we are in the Design and Mechanics division. Professor Lin, he is working on. You can see he joined micro technology and biomedical. So he has some experience of nano fabrication, and he used a lot of optical technology as well, and he used it for biomedical applications. So if you are, I recommend you guys to use this course to learn more about those professors, and later on, maybe in your sophomore year, you can start to find opportunity to probably talk to some professors, send emails, or maybe the best way is to send an email. Just tell the person that you get the opportunity to learn about what he works on from the internet or from this course, and you're quite interested in that professor's research direction, and arrange an interview or a short meeting with him. And if he is interested in you, maybe he will reply with positive response. So writing an email in a polite way or appropriate way is very important in Taiwan. So not only Taiwanese and also foreigners, please write your email politely. Don't treat the email as a messenger. Do not send it, don't let you guys do that. When you send an email to a professor, you say nothing about yourself and say, can you write a recommendation for me? Without letting me know who you are. And I know I was undergrad in your age, so I know how young people think, right? I was like you guys. I don't care about what the professor said, but I just want you to know those are important. Those affects your future. So if you get to know about those, the earlier, a better future could be closer to you, because those will be could be affecting some opportunities. Okay, so anyway, back to here. So that was Professor Lin Dingzhen. The other professor here, he's also in micro fabrication, I think, like semiconductor. He's Professor Li Yuqing. So no. So Professor Li was in TSMC. Do you know TSMC? The Taiwan Semiconductor manufacturing company, the largest semiconductor company in the world. Okay. So he was from TSMC. Then he went to another technical university for assistant professor. After he stayed there for, I think, 3 years, he was promoted to here. Okay. Now, they are both in Design and Mechanics division. In the manufacturing field, let me introduce the young ones. These three are the most junior ones, even though this person is not looking young. He's not. Okay, Professor Zhou Shuoyan. Professor Zhou, he's a manufacturing professor. I don't really know what he's working on, but he's from manufacturing. Okay, Professor He Yujian. Okay, I'm trying to remember his Chinese name. He Yujian. His research is about metal forming, and microstructure property analysis. So Professor Kobayashi, Hirohito Kobayashi. From his name, he sounds like a Japanese. Yes, he's half Japanese, half Taiwanese. Okay, so how come we have a Japanese professor? He actually worked in USA. He was a professor in USA, and recently, I think his parents became old, so he would like to stay closer to his parents. So he decided to travel back to Taiwan, and he has basically two homes, a home in Japan, a home in Taiwan. I guess he followed what I did. His wife, I think his wife is Taiwanese. So I guess he followed his wife's decision, like what I did. I was supposed to teach in USA, When I was a PhD student, I stayed in Rutgers for 7 years. Rutgers is the State University of New Jersey in USA. I stayed there for 7 years. I completed my master, PhD, and I stayed there for 2 years for postdoc. In total, 7 years. That was the time my advisor said, why don't you just apply for green card and then continue to work for our department? So eventually you will become a professor, and 10 years later you will be promoted to full professor, and then my advisor can retire. That's what he wanted me to do, but that's not what my wife wanted me to do. Yeah, I don't mind talking about this in the video. Yeah, she wanted to come back to Taiwan, and that's why I never submit any application to USA. I sent all the work job applications to Taiwan's universities. Anyway, I guess that's why he came back to Taiwan, and we were lucky that he can join us. So now we have a professor who's good in English, Japanese, and Taiwanese. And he's a manufacturing researcher. He also works on non-destructive testing. So I know students from GTEC, you guys are looking for opportunity to study in Tokyo Tech. I would recommend you to talk to Professor Kobayashi more, because he knows about Japanese culture a lot. Maybe you can practice Japanese with him if you want. Okay, that's the junior professors in manufacturing field. Then thermal and fluidics. Let me introduce the junior ones. They don't have junior ones. Everyone is quite senior. Okay, so they recently didn't hire junior ones. In control, actually, our president is a junior professor in our school. He's new professor. He was originally in NTU, our neighbor. He was the dean of engineering in NTU, and 2 or 3 years ago he joined our election for president, and he won. So he became our president, and since he started his position in Taiwan Tech, he has to transfer his position to here. So he has to quit in NTU. So we were lucky that we get a really experienced professor from NTU. So he's now our president. But his years in Taiwan Tech is not long. Was not long. So let me introduce you this guy, Professor Zhuangjing Wei. He's a very new professor. His expertise is in control, multi-robot system. So he right now is trying to build a system with a lot of small robots. He tries to make those small robots communicate with each other so they can work like a team, okay? Like we call them a swarm, like a swarm, okay? So if you are interested in programming and would like to work with some small robots, you can talk to him. Okay, now I will talk about the rest when I use the PowerPoint. But in the PowerPoint, I don't have everyone. That's why I need to cover the new professors. So in material field, these two are the newest. Professor Cai Bingjun. Cai Bingjun is also in micro technology. I think he's in energy, like battery research. Okay, so nowadays, energy-related research are so popular. So even mechanical engineering professors work on something related to energy. Professor, what is his name? Cai Rongting, yeah, yeah, Cai Rongting. He's he's a 3D printing guy. 3D printing, composite material, non-destructive testing, yeah. So I went to an international conference this year. I met his advisor, so he was very happy. Oh, you are Cai's colleague. Okay, anyway, now I can move back to my slide, where I have more details. So Professor Zhao is the most senior professor in Design and Mechanics division. If you would like to know which division the person is, he's in my division, Design and Mechanics. He's very senior, and he's about to retire in a few years. So if you would like to find him for projects, he probably will assign you to a younger professor, Professor Xu Qingqi. Professor Xu, our vice chairman, is Professor Zhao's student. So if you try to work with Professor Zhao, probably he will introduce you to Professor Xu. Okay, so he is in biomedical engineering, biomechanics. Okay. Okay, Professor Lin Qiyu is the past director of Robotics Center. He basically worked on all kinds of robotics. Similarly, he is about to retire. If you later on would like to work with him, he may assign you to me because I'm the current director of intelligent robotics. Okay. Professor Huang Songren, he's more like a material background. He has material background, but he's in the division of design and mechanics. He works on composite materials and some other like biomedical mechanics and so on. So his research is more related to materials. Okay, Professor Shi Yipei. She is the master of gear mechanism. Okay. I put everyone's major research direction on the lower right corner. She's the gear master. If you have any questions about gear, then she's the person to talk to. Okay, Professor Chen Bingchen. Previously, he was the vice chairman. Now he's in USA. He's in Texas right now. Is there anyone from USA? No USA this year? No? Okay, that's fine. So he's in Texas, USA right now. He will be serving as like an international officer for Taiwan in Texas. He works on micro fabrication and mostly micro devices. Okay. He's also involved in the third division, the biomedical engineering. I think you can say he's the founder of the biomedical engineering division. Okay. This person went to Yangming Jiaotong, so ignore him. He's not here anymore. Okay, Professor Li Weizhen, he's a senior professor in our school. His expertise is in mechatronics. Okay, like I said, he has the experience of integrating electronic systems with mechanical systems. Okay, so he did a lot of robotics as well. Okay, Professor Xu Jingqi, like I said, he's the current vice chairman, and he's the student of Professor Zhao Zhengang. So his research direction is quite similar to Professor Zhao. And he also works on biomechanics. I think he's also in biomedical engineering. So this is myself. As you can see, it doesn't look like me. I think that was 10 years ago. Okay, I'm actually an optimization guy. I work on optimization, a very mathematical and statistical research. When I came back to Taiwan, forced by my wife, recommended by my wife, and I started to find my own research direction, and then I realized in Taiwan, you cannot just work on theoretical stuff. You need to apply. And that was the moment that I found I can apply optimization to robotics. Okay, Professor Xie Hongling. He's the optical research expert, optomechatronics. So if you are very interested in anything related to optics, you should talk to Professor Xie. Remember earlier I said the director is Xiufang Zhong, right? But Professor Xiufang Zhong, who built the Paraguay Technical University, is too busy. You cannot find him. But Professor Xie is more possible to find. So if you are interested in optics, you can find Professor Xie. Professor Chen Yuxun, she's the mechanism, she's also in mechanism. Her research is quite interesting. In the ancient years, like ancient mechanism, let me show you. In the old days, we have like a mechanism designed hundreds of years ago. Okay, something like this. It doesn't look like something from the modern years, but they are like a really old mechanisms designed by people hundreds of years ago. At the time, people didn't know how to they didn't write papers about this. Okay, so there is a group of researchers nowadays in the world try to redesign or try to figure out how to make ancient mechanism. Okay, so if you are interested in ancient mechanism recovery, you can talk to Professor Chen Yuxun. She probably is one of the very few professors who are working on this in Taiwan. So if you are interested in those, she will show you a bunch of books about ancient mechanism and then invite you to join her world. Okay, we talked about Professor Lin Dingzhen already, Li Yuqing already. Now, we move on to the manufacturing division. Professor Lin Qing'an is very senior. He's famous for CAD-CAM. computer-aided design and computer-aided manufacturing. Actually, his name was so commonly seen in so many CAD textbooks. Let me show you. Those books has his name in it. He's a master for CAD, okay, and Pro E. Actually, when I was a student, we bought textbooks of Pro E with his name in it, but not knowing who he is. And after I come to Taiwan Tech, I realized, hey, how come this person is my colleague right now? He's so famous about this. Okay, so computer-aided design, he's the master. But he's very senior, very close to retirement as well. Professor Zheng Zhengyuan is the most senior professor, like a distinguished professor in Taiwan for 3D printing. He's the director of High-Speed 3D Printing Center. So if you have any questions about 3D printing, if you go find this professor, he will definitely know the answer and show you a lot about 3D printing. Okay? So just remember this person. He's a 3D printing expert. So Professor Chen Zhaozhang, like I said, he's the CMP, the Polishing Innovation Center. He's the director right there. And I think he's now in E3. Do you know E3? So for foreigners, if you don't know E3, you should know. E3, Industrial Technology Research Institute. E3. E3 is the governmental research institute that built advanced research or technology for the industry. It's in Hsinchu. Okay? So do we have trips to E3 in this course? Let me see. We go to TSMC, right? Not E3. Okay. The E3, the TSMC trip will be more interesting. Okay. So I think Chen Zhaozhang is in E3 now. Let me check. Yes, I think he's still there, if I'm right. He basically went to the E3 to serve as their vice CEO, something like that, for advanced measurement. Okay. So sometimes professors in Taiwan will be borrowed by some other company or research institute. So sometimes we go outside to serve as their important leading person for 1 year or 2 years, and then we come back. So I think he is very hard to find. Professor Xiu Fangzhong, the founder of Paraguay Technical University, so he is also hard to find. Okay, Professor Zheng Yiling, she's another Professor Zheng who is working on 3D printing as well. So she even knows how to build a 3D printer. Okay, so in her lab, many students truly built their own 3D printers. So if you are interested in that, you can go find this professor. Okay, Professor Zhang Fuyu. Professor Zhang Fuyu is a professor who works tightly with the industry, and mainly about micro and nano fabrication. I know he has a lot of industrial experience. So if you are interested in micro and nano fabrication, manufacturing, you can go find him. Professor Guo Junliang, he is the master of machining. So he knows a lot of techniques for machining. He was the leading person for our workshop. So, but now he passed this duty to another junior professor, and he understands about various ways of machining. So now you can say the managing professor who works for the workshop is this Professor Zhou Yuzhen. So he basically works on manufacturing of fine materials, like powders or films. Okay, Professor He, I mentioned, he was in metal forming. Now move on to thermal and fluidics. This is our dean, who doesn't look like him. You know, we professors use the pictures 10 years ago and never want to change it, because we cannot find a better picture. Okay, so Professor Chen, he's an expert in CFD, computational fluid dynamics. His lab write their own codes for simulating fluidics. So if you're interested in CFD, computational fluid dynamics, you can go find our dean. Professor Huang, he's the master of thermal fluidics. He has so many inventions. I remember he has an invention about how do you call the machine that you put on top of your when you cook? That venting machine? How do you call that? When you cook, how do you call that? What's the English of it? Ventilation. Ventilation. Yeah, or exhausting fan. So exhausting fan. Yeah. So basically, not those. How do you call that? Pilot. Ventilator, yeah. So, ventilating the oil and stuff, right? So he has inventions for those. I remember he has an invention where he asked his graduate students to cook. So when the student cooked, there's a lot of smoke of oil, and he invented how the smoke of oil passed through some kind of streamline and then being dumped away by this his invention, and you can cook in front of it and you won't be able to smell the smoke because it was 100% being ventilated by his invention. So Professor Huang Rongfang is a master of Yes. So he invented a lot of machines and systems in the real world. He's a master. Professor Lin Jianqun, he's my neighbor. His office is next to mine. He works on various kinds of fluid dynamics, like a turbo engine, gas dynamics, and so on, turbo machinery. Okay. Professor Lin Yijun is the expert also in fluid, thermal and fluid dynamics. I'm not very sure about what's the specific research field in thermal and fluid, but he's from UC San Diego. So if you are interested, you can talk to him. Professor Wen Chongyi, he has quite unique research direction where he handle nanoparticles, collection of nanoparticles. So it's really important for manufacturing. For example, you have you are machining carbon material, and you have small powders of small carbon particles. If you inhale and then let it go into your body, you cannot get it out. So he's an expert in handling those nanoparticles. Okay, Professor Tian Weixin, I know he taught a lot of students to build fluidics machines, even including flying wing. So I think in the past he even brought a group of students to Japan to participate in some kind of flying competition. So basically you build large flying wing, and then people stay underneath and then try to fly. Yeah, like a birdman. I think the competition is called the birdman competition. I know he did that. So Professor Su Yuxuan, he is, I think he's more like a mathematical researcher, mathematics. He is a mathematical researcher. He's really good in math. I know students sometimes will send him direct message about some math problem, and he usually gives back the answer in a very short period of time, even it's after midnight. That's what I think he's famous for that. Anyway, Professor Zheng Xiuyang, he is also in the thermal and fluidics. He is more he works more in MEMS. What is MEMS? Micro electromechanical system. Let me show you what is MEMS. So, super small devices. Super small. This gear probably is in the size of like the diameter of your hair, micro scale, super small. Okay, and how do we see this? We use SEM. What is SEM? Scanning electron microscope. So they are so small, you can only observe those, use super fine resolution microscope, SEM. And I know Professor Zheng Xiuyang is working on MEMS, but he didn't work on some devices like gears. He works on microfluidics. So something like like fluid channels, but in a very fine scale. So we can even have a circuit system on top, something like those. Okay? Now, our president, we move on to the control division. And our president is working on nano manipulation. So basically, the system he makes is able to manipulate, basically like moving in a very fine scale, very fine precision. Okay? And usually, students do not dare to ask him whether you can work with him. So he sometimes cannot find good students. So don't be scared. If you are interested in working with our president, you can send him an email. He will be very happy to see emails from you asking for opportunities to work with him. Okay, Professor Huang Anqiao is a senior professor in the control field. He is famous for nonlinear control. So if you later on learn some courses in the control courses, many of the times you are using linear models. And when things get more dynamic, linear models are not good enough. So we will use something called nonlinear control. It's more challenging. And are you able to control a system in real time? Professor Lin Jiying, he's also very senior. He's also in working on control, and specifically for precision control, and use it for some robotic systems. Okay, so he's also a member of our robotic center. Working with him usually can have really good publications. So Professor Lin Jiying is really good in publications. In my teaching career, sometimes I will take some students to participate in some robotics competition or paper presentation competition. Sometimes I will meet sometimes I met Professor Lin Jiying and his students. I never beat him. So if you work with him, you have good chances to win some kind of award, maybe a competition or some international activities. Okay, how many time do I have? I have 1 more hour, right? Okay, Professor Xu Jisheng. Professor Xu is the AI professor in our department. So he works the most on AI, computer vision, pattern recognition, face recognition. Okay, so if you are interested in AI, you can talk to this professor. Okay, Professor Chen Liangguang, he is working on vehicle control, automotive. Okay. So I know he's also involved in a very new research center in our school. It's called electric vehicle, EV. So nowadays we are trying to use EV cars more than gasoline cars. Because, maybe there's one day we are out of gasoline, then we can use electricity. So EV cars are, electrical vehicles are a very popular research direction, and Professor Chen Liangguang is one of the researchers who is in charge of the EV research direction in our school. Professor Jiang Jiarui. Professor Jiang, I remember he's also involved in vehicle control. So Professor Chen Liangguang and Professor Jiang Jiarui, they are both in vehicle systems. I remember they tried to buy a new car, and they tried to control the car by computer. And I remember they built their own cars, like F1 cars, racing cars, in the past. Okay, Professor Liu Hongkun, he is working on control, mechatronics, and mechanical design, actually. So he is also quite involved in Industry 4.0. Okay, so he's a junior professor, but I know he also took many students to participate in some competitions, and his group sometimes will win the prize. So if you want to have some hands-on exercise on some kind of mechatronic system, you can go find this person. And Professor Zhang Yiquan, his research background is quite similar to Professor Liu Mengkun. Okay, but Professor Zhang works on precision measurement as well. Professor Lan Zhenyang, these three professors hang out together quite often, so their research directions are quite similar. But Professor Lan is also very famous for fault detection. So for any control system, there could be failure, and he's the professor who identifies signals from the system and then realize whether there's a abnormal event. Okay, finally, we move on to the material division. Our chairman, Professor Guo Yuling, he is famous for plasma technology, specifically atmosphere plasma. Do you know what is plasma? Let me show you. Have you heard of plasma TV? Plasma. They don't look like plasma. Okay, yeah, like the lightning is a kind of plasma. Okay, plasma. So usually, if you want to see plasma like this, you need vacuum or super high energy. But Professor Guo Yuling, he doesn't use vacuum, and he was able to generate plasma in the atmosphere environment. Okay, so atmospheric plasma, that's what he is famous for. Okay. Professor Wang Chaozhen is famous for corrosion. So I know he has a lot of collaboration with the industry, because everything you build, you may have corrosion issue. So like a boat, the surface of a boat may have corrosion several years later, because there's salt inside the ocean. So the surface of a boat will have corrosion issue. Okay, so Professor Wang is famous for corrosion research. Professor Zhou Zhenjia is famous for microfabrication in the material field. Okay, so we can see he works on material science, various kinds of material research, but mostly focusing on microtechnology as well. Professor Zheng Weijun is an expert in surface and interface science. So I think this is more theoretical, and when you work on various kinds of materials, specifically on semiconductor. There are some issues at the interface between various kinds of materials. Then there are some research to be done at the interface. Okay, Professor Chiu is working on energy storage. So he's looking for materials that, basically battery materials, okay, like hydrogen storage, very famous research direction. Okay, forget about this person. He's also in Yangming Jiaotong. So it's very common to see a professor being promoted to somewhere else. Like myself, I was in different university and then I move on to Taiwan Tech. It's very common, so don't feel weird. Okay, I talked about Professor Tsai already. So now I spend a lot of time going through every person in our department. Now I would like to spend a little bit of time talking about myself and encourage you to work with me in the future. Maybe I will show you cool stuff. Okay, not this one. There's a picture of this. I built a super large robot. Recently. So the reason why I built a super large robot is because now in a factory, they sometimes would like to build a layout like this, where you have different stations of different kinds of system. For example, this is for the tools, like storage for tools. You may have storage for the workpiece. You can have a station for measurement. You can have a station for cutting and turning, lathe turning or milling and so on. You can have, it's like Lego. You can, plug and place. Take out one machine and put another one here. Or you can make this layout longer. So ideally, you can do that. However, after discussing with the industrial people, they told me, this idea is pretty good. You have quite flexible opportunity to build your own layout. Once you build a layout, usually you don't want to make a change. Because making a change costs money, costs time, so they just want to build something and then use it to make money. So there's a disadvantage of using a layout like this. The disadvantage is the robot in the middle. The robot moves along a guiding system, like a linear guide at the bottom. The linear guide occupies a space. No one can come closer to this area because there's a robot moving on top of the guide. So we propose we should use something different. We should build a moving platform like this. So we don't need a guide. We just need to build a robot like this with wheels, so it can move around inside the factory. You don't need to have a guiding system. Okay? And this is what we have. So has anyone been to the workshop in our department yet? Workshop, do you know workshop? 工厂. Never? Not yet, right? You guys are only freshmen. Later on, you will know in our department there's a workshop. So there's a kind of machine, this is called lathe. What is a lathe? Lathe machine is like you have a cutting tool, and then you have a workpiece. You spin the workpiece, and the cutter comes closer to cut the workpiece. So for example, if I'm making a product like a cylindrical shape, and I think the diameter over here is too large, I need to shrink the diameter. I can use a cutter to remove some materials on top. Usually it's done by so-called a lathe machine. Lathe. Okay? This is a lathe machine. And there's another kind of machine, it's called a milling machine. Milling is different. Milling has a cutter on top and your workpiece at the bottom. This time, they don't spin the workpiece, they spin the cutter. Okay, so it's like a drill. The drill cut through, remove material on the workpiece. Those machines are quite large actually. And from here you can see my student try to build a, I feel like it looks like a tank in the workshop. In the workshop. It has a similar size as the lathe machine. Okay, let me ask you guys, I think the Taiwanese know. For the foreigners, do you know what is that? A bag of green, what is that? Do you guys know for foreigners? Taiwanese know. It's a bag of cookie. Do you know why people do this? Put a bag of cookies, only this brand, only this flavor, coconut flavor, on a machine. Foreigners. Not for success. Okay, do you recognize this word? Guai guai. Guai is the opposite of naughty. So stay nice. So if you say this to your kid, it's like, okay, don't be naughty, be a good kid, be a nice kid. Don't do anything naughty. So this brand is called Guai Guai, and somehow they have this coconut. It's like it tastes like a coconut puff, and when they first have this flavor, people start to put this on their computers, on machines, because green light in Taiwan means good to go, no failure. Red light means failure. So they want their machine stay green light all the time. And green is the good color for normal operation without failure. And their brain is called Guai Guai. It's like you are talking to your machine, stay good, don't do anything bad, don't fail on me, I want to graduate, something like that. And after a while, this company realized, okay, we can have new flavors, but we cannot stop this one. Because people from the industry buy a lot of those, but they don't eat them. They just put it on top of the machine. Okay. So let me show you, see? This is like a server in a computer. Then let's see more. Yeah, this is a cutting machine. This is a cutting machine, right? And you see, you can even, they have an area where you can, write down your own words. What this means, okay, the printer be nice, don't do something silly. put it on top of the printer, you know. People in the office, sometimes they want to print something and then the machine just keep on jamming. So people just put a bag of this on top and say, be nice, printer, don't do something silly. Yeah, like this. Do not make trouble. So you can write down your own stuff. Anyway, it's only, I think only Taiwanese know. Probably anyone from other, because this is a Taiwanese cookie. So you cannot find it in Hong Kong, you cannot find it in China. Well, anyway, we built this, and this was done 2 or 3 years ago. Now, let me show you what does it look like. Don't call me. Now we already put a robot on top. Let me see. Yeah. This is already built. We have a robot on top. So this robot is super large. Let me show you how large it is. This is my student who is trying to test how much weight this robot can carry. And from the spec, the manufacturer said this robot can carry 70 kilograms. This student is around 70 kilograms. So, human testing. Another human testing. 2 students testing the robot. Yeah. Okay. So in my lab, I work on robotics and a bunch of cool stuff. This one I think is pretty good as well. Let me see if. So in the factory now they are looking for human-robot collaboration. So this is trying to explain how a robot can work with the human. Sometimes you want to ask the robot to deliver something to you, but not punch me in the face, right? So you need the robot to recognize what you're doing and where your hands are, where your body is. So we keep all time monitoring what the person is doing, what is his gesture, what are the coordinates of the arms. If at the moment there's an agreement of delivering up items, the robot will drop its safety level and try to get closer to the robot, to the person, and try to deliver. However, in some other times, when the robot is not supposed to have a good distance with the human, it will try to keep away from the human. So that was the video where the student was not supposed to have contact with the robot. So she was trying to block the trajectory of the robot, and the robot realized it and then found a different trajectory and passed around the human. Let's take a look at the demonstration again. So the robot was grasping an item and trying to move it to the workspace, and the student was trying to intentionally blocking the way, and we realized, hey, why are you doing this? So the computer realized she reached out without agreement. So the robot was not supposed to have contact with the person. Then the robot realized computes for a new trajectory and then move around her arm. So that was two of the many research directions that I was doing recently. So for mechanical engineers, so I don't need the slide anymore. If you graduate, what can you do? I think the easiest job that you can do is to have become a CAD designer. So you learn how to use computer graphical softwares like SolidWorks, Pro E. You start to make engineering drawings of mechanical parts. Because for any machinery or mechanical design company, they need to manufacture some mechanical parts. Before manufacturing the part, they need to have engineering drawings. So if you are interested in making drawings, let me show you how this look like. So you learn how to make a drawing like this. Like this is a mechanical part. Not having good. Like this. Okay, this is a mechanical part. You learn how to build something like this in computer, and then you will try to draw the 2D views, top view, front view, and right views of those. So the manufacturer understands what you mean about the geometry of the part. So they can make the exact item based on the drawing you made. Okay? So as a mechanical engineer, CAD designer is such a common job for mechanical engineers. And this is not the only job you can do as a mechanical engineer. You can operate various kinds of machines in the factory. And from our division, you realize you have design, you have mechanics, thermal and fluidics, control, material, and also, I missed one of them, manufacturing, right? So we have jobs in all those fields. And if you graduate as a mechanical engineer from Taiwan Tech, it's almost impossible for you to fail on finding a job. I feel like in Taiwan, it's so, the only issue is to find a good job with good salary, less workload. That is hard, right? And I always tell my students, the worst job you can get is to get a job in TSMC. TSMC pays the most, but it's like you exchange money with your labor. Because you need to work double harder than others. You have night shifts, and it's no kidding. It's very tiring, right? And that double the salary. My students are making more than me, who works in TSMC. So sometimes I told them, you don't need to go to TSMC. You can, that's of course paying you the best. You can find a better job with also good money. So, do you guys have any questions? I'm reaching the end of my introduction. I just want you to know who are working on what in our department, and then if you're interested, you can talk to them. And it's quite multidisciplinary. we rarely touch chemistry, but there are some professors in our department who works on chemical stuff. Even myself, I work on silicon rubber and some polymers, but I'm not the expert of those, but I sometimes still use chemical stuff. Mechanical engineers usually, so the difference between us and civil is that we don't touch chemistry, right? The difference between us and civil engineer is that we don't build the buildings, but we do need to work on some important components inside the building. For example, air conditioning. Mechanical engineers build an air conditioner, but we don't care about. It's not like we don't care. We don't focus on how to build a building, like concrete. Yeah, we don't learn about the mechanics of concrete. We usually learn the mechanics of metal. So in chemical engineering, many times they work on polymers. We work on metals. In civil engineering, they work on concrete and steel. And in material science, they work on all kinds of materials. But they don't, in material science, they sometimes don't build something. If you want to build something, probably you need to come to mechanical engineering. Because in our department, at the end, you sometimes need to build something. Okay? Any questions? All good? Okay, great. So that's it for today. If you have questions, you can talk to the TA. Next time is, I think 2 times later is you. Okay. Yeah, question? So important. Okay, so good question. We are really good in whatever that is moving. So let's say you see, for example, this is moving, right? Only mechanical engineers design this. No one else designed this. There's no other department or any field that will teach you how to. Of course, in like a industrial engineering people, they may worry about how it looks like, but we worry about the function. So this mechanism is trying to carry the load of this monitor, and it has to be able to do this for probably 1 million times without failing. And there's an important design concept inside to figure out how strong each part is. So, like if you ride a bicycle or motorcycle, there are chain systems. Those are only designed by mechanical engineers. Yeah, so whatever that specific, most of the time we are designing something that moves, that has some movement. So who designed this? The chair? It could be designed by a mechanical engineer, but maybe can be designed by someone else, not mechanical engineers. But if this is moving, if the structure moves, that has some kind of mechanism, like maybe this chair has some electrical system. I can sit on top, I can control it, so you change its gesture, it's an angle, so for that kind of design, I need mechanical engineers. Okay? And what's the difference between mechanical engineer and electrical engineer? Sometimes electrical engineers only care about the electronics. They don't care, okay, how large the table should be, what's the material you should use, what kind of screw that you're using, they don't care. They only care about, okay, there's a mass which is gonna lift up or lower itself when you control it. They only care about, okay, what kind of motor that we use. And so that they have a panel so you can move up and down, and then maybe the level of the table moves up and down. That's for electrical engineers. But for mechanical, you need to design the whole thing. I think we care about the system, the whole system. Yeah. Okay? Yeah, go ahead.
I have a question about one of the research focus that you just mentioned about the micro and electromechanical systems. Why would we even need something that small to?
So small? The MEMS?
Yeah.
Okay. There was a dream about MEMS probably 10 years ago or 15 years ago. They want to have such a small mechanism so you can have applications such as surgery. Actually, we do have some micro devices for surgery, but not very popular. So they have dreams of using such a small devices that probably cut something inside your vein or whatever. But I think right now MEMS is most commonly used for sensors. Yeah. In fact, this is a sensor. What is this? So they use micro technology to build something like this. They call them the comb drive. So they have something like this, and because it's so small in a micro scale, this cantilever is so thin, if you have contact with it, it vibrates. So if it's vibrating, you can check its electrical response between those combs. So it becomes so sensitive and can realize vibration. So vibrational sensor is made by this. So yeah.
And one more thing, how do you even manufacture something that small, that's even smaller than some tolerance range for most components?
Okay, so there's something called microfabrication. So usually it starts with silicon, a flat surface of silicon. We call it silicon wafer, and then there's a bunch of chemical process. There's something called photoresist, where you can apply optics on top, and you can block some of the area and not blocking the other areas. So the photoresist become harder for the area that you put lights on, or become softer. Anyway, you are able to pattern it later on, so you have like a small holes like this, and then you can have more process. So this is demonstrating how you can imprint and get something like a Lego. This looks like a Lego, right? But this is just one of the way to have very small scale item like this. So since this is done by optics, laser lights could be in such a small dimension. So we can pattern geometry in such a small dimension. So you can make something so small. Yeah. So that's what microfabrication is about. And what happened in semiconductor is they're using microfabrication. If you are able to have some kind of microscope and take a look at what's inside the circuit chip, this is how many layers it could have. So many layers, and then you see something that was like embedded inside. It was done by tons of microfabrication that I was mentioned earlier. So they do this layer by layer. It's like stacking a steak, like 1,000 layers of steak. Sometimes they take something away, sometimes they apply new things on top. So imagine you are learning electronics and then trying to build some kind of circuit by yourself. You have wires, you have a resistor, you have battery and so on. Imagine shrinking those into micro scale. That's how you do it. And that was invented tens of years ago. And now we are able to, people say 3 nano technology means the smallest geometry is in the width of 3 nanometer. TSMC, 3 nanometer technology. Chasing by Korea. Cannot lose to Korea. Is there any Korean here? I'm sorry. Okay. Any other questions? If no more, that's it for today.
I made a Google Sheet for them to investigate whether they want to join the TSMC tool.
Okay. Okay, so the TA is trying to collect something about the TSMC tour. So please follow him to provide some information.
Help me to explain this. It's a Google Sheet. Let me know whether you want to join the tour. Okay. I have a question about the tour. We'll see how the tour works. Your English name? Huh? You mean the process? Yeah, English. And when is it? 11.
Maybe we talk about it and then but I think they are really
Do you have a
so the ones who
Okay, see you guys. Bye bye.
I will upload this to Facebook and Moodle. Yeah, so you can be a little bit change. Yeah. From here, and we will keep it from here.
Okay, if you guys have done this, just give it back to me and write down your student ID and your name.
Initially, I wanted to like they're something simpler, right? But after this was bigger, it's kind of repetitive. I kind of
I will upload the information and the QR code on Facebook and Moodle, so don't worry.
And then there's this.
Oh, yeah. I forget there's groups.
There's quite a lot. I guess I like wait I'm also excited for holiday. I mean, like, for using it, I'm just excited to, like, meet members. Yeah, probably. Because I'm not sure if my friends will come here or I go back to my home country. All I'm certain is that I will.
1点到5点。
Yeah.
哦，没有10
So you'll be staying.
11点。哦。
Yeah, if we did it, but it's just from America down here, right?
没有吧？
他只是中餐，12点40到4点，就是1个小时吗？原来是1个小时吗？有人去追踪你？嗯？TSM 是1个小时。我上连物理课都还有什么？对，我的那个。北部是 including 新竹北澳的中文。但是给我一次，然后就是2个拿过来，过来给你1个哪有一个小时？没有，但是。Yeah.